why don't you first give me an example of a chemical or a physical change?
So a physical change, I'll just use almost like textbook examples. A physical change would be when you split a piece of paper in half.
Okay. So you said physical. You said breaking or tearing or ripping.
Yeah.
Ripping paper. Okay. I'm not going to comment on that much. Okay, give me an example of a chemical change.
And then a chemical change would be baking soda and vinegar reacting, and then there's gas that emits. I think it's carbon dioxide that's being emitted.
So you've got baking soda and vinegar, and they produce a gas. Those are really classic examples. And for some reason, they work for lots of people. They don't really work for me. And I don't think they work for a lot of students. Why is ripping paper a physical change in your mind?
Well, when you rip the piece of paper, you're left with two halves of a whole. It's both of the pieces are still pieces of paper. I think everyone can get behind on that.
Okay. All right. What about in the second one, in the chemical change? Why is that a chemical change?
I think even in cartoons they depict this. It's the bubbling of the baking soda and the vinegar. There is a gas that is emitted. You might not be able to see it as well, but
there's my gas being produced, right? It comes out of the solution or whatever, right?
Yeah, but when the reaction is all done and set, you're still left with something white, and someone could mistaken it for baking soda still, I guess. So I guess that doesn't really help too much explain the difference between physical and chemical change.
Yeah, I think it's hard because are you making and breaking bonds in either of these cases?
Yep, you're breaking and creating bonds. I believe in the chemical reaction.
Right? In the chemical reaction, it's very easy for a chemist to look at that and say, yeah, we have broken some bonds and we've made some bonds. But I know that after having been a chemist for 5 years or 10 years, right? How do I know that in the baking soda and the vinegar that I broke some bonds and I made some bonds when I'm a beginning chemistry student? I have no idea how you know that. It doesn't make any sense to me at all. Likewise, if I looked at the physical one, when I ripped the paper in two, have I broken some bonds?
As a chemist speaking, no.
Are you trying to tell me that there's no chemical bond holding those two pieces of paper together? Some intermolecular forces?
There might be some intermolecular forces, but I don't think you're technically breaking any bonds, which might lead to the confusion you're trying to get to.
Yeah, no kidding. I just think that it's hard, that if you're already an accomplished chemist, this is easy. But in the case of our students, well, they're supposed to know this. It's just not clear to me. How about this? Let me give you a better one, or one that's even more of a challenge. What about this? Okay, so I've got a pot of water or a beaker of water, right? And I make my water, and it's a liquid, and I put some heat to it. And now all of a sudden, it starts to boil off. and now I've got some water as a gas. Is that a chemical change or a physical change?
By the book, that's a physical change, Dr. Hunter.
I know, but what am I seeing? Bubbles come out of the top, right? A few seconds ago, back on this page, you had a gas being produced out of a beaker just like this, and you said that was a chemical change. How am I supposed to know that, right? What about this one? I've got H2O as a liquid, and I'm going to do something to it. I'm probably going to throw a catalyst in there, or I might throw some electricity or something. I might do something in here, and I'm going to produce hydrogen gas and oxygen gas. Okay? Is that a chemical change or a physical change?
That one is a chemical change, I believe.
Because I've written it this way, right?
Yep.
What's my beaker going to look? What's my beaker drawing over here going to look like?
It's just going to have some wires in it, or
Sure.
whatever you do with it
To make it
look the same.
I have some bubbles of hydrogen come out, and I'm going to have some bubbles of oxygen come out, right?
Mm-hmm.
So I look at this and I say, how the HE double hockey stick is anybody who's a beginning student of chemistry supposed to know the difference between a chemical change and a physical change? If you come back in 5 years' time and you can't do that, right? You're doing a great job of this, right? You've been studying chemistry for 2 or 3 or 4 years, right? From the first time you started till now, and you've got it down cold. But if this is your first time, or anybody's first time in a chemistry course, trying to figure out the difference between a physical change and a chemical change, or a physical reaction or a chemical reaction, I think it's a real challenge. So if you're struggling with what seems to be such obvious concept, don't feel badly about the struggling, because it's a very rational struggle, in my opinion, to try to figure these ones out. And so once you become an accomplished chemist, maybe further into this course or after a couple of others, maybe you'll be able to have a large enough body of knowledge that you'll be able to say, oh yes, if I've got water and it's producing hydrogen and oxygen, and somehow I know that those are different substances, I must have had a chemical change. But if you're looking at some symbolic representation like this, or if you're just looking at a beaker where something is happening, it's not clear to me how you're going to know those things. But your textbook definitions back here of ripping a paper and it's still being paper, no new substance produced, or a chemical change where you've got some new compounds produced, that's exactly the way it is. You've nailed it in terms of the examples and the definitions. But it's only because you have a lot of experience as a chemist that you're able to identify correctly whether or not they're chemical or physical changes. What other things, us having this discussion, what other things does it make you think we should add at this point about chemical and physical changes?
I think, for me at least, it's easier to think about it on a particular level, at the molecular level. Because if you think about the paper and then you think about the baking soda and vinegar reaction again, if you zoomed in all the way to when you were tearing a piece of paper up, you still have the same atoms making up the same molecules arranged in the exact same way, but now you just have two separate parts. There's just a wide gap between them. But then you can actually see in the baking soda and vinegar reaction, you can see that some atoms are being rearranged. And they make new molecules, which I know is already the textbook definition, but sometimes just thinking about it, taking a step back, saying, hey, are there any new molecules being formed here? Or am I starting off with something and then ending up with something different? Is that happening? That can kind of help you sometimes, just taking it slow.
Yeah, I agree with all of that, but it's not trivial. If you can actually pull off chemical and physical change, you're actually a pretty accomplished chemist by that point. So congratulations.